Let's get started. My name is Daniela Rus. I'm the director of MIT's Computer Science and Artificial Intelligence Laboratory, or CSAIL, and I'm delighted to be here with you today to introduce our distinguished guest, Professor Deborah Estrin. Deborah is joining us from Cornell Tech, where she is the Robert V. Tishman 37 Professor. She received her bachelor's in computer science from Berkeley and her PhD in EECS from MIT, so she's really one of ours. Deborah started her academic career at USC in 1986 and then moved to UCLA in 2001. Her research founded the field of sensor networks, which is a revolutionary development that laid the foundations of the Internet of Things. And her visionary leadership led to the creation of SENSE, the Center for Embedded Network Sensing, which really galvanized the sensor network community. Her work really transformed how we capture and utilize data in our environment. So, I often think about whether data could dance. So if data could dance, Deborah would be the choreographer. Now, in 2012, Deborah moved to Cornell Tech, where she continues to use mobile devices and sensors to collect and analyze data. And she's particularly focused on applications for healthcare and well-being. She continues to work in this area on multiple fronts. In particular, she's the founder of a nonprofit startup called Open Health, where the focus is on data sharing standards and tools that allow developers of health applications to store, process, and visualize data. So Deborah Estrin is the recipient of many awards. I would like to highlight 3 of them. She is a MacArthur Genius. She's a member of the National Academy of Engineering, and she's a member of the American Academy of Arts and Sciences. And I personally admire so much her ability to be such a visionary thinker while maintaining strong and creative intellectual curiosity and commitment to the greater good. So we're honored to have her here with us today. Please join me in giving Deborah a warm CSAIL welcome.
So thank you. I think was the CSAIL was the event you guys did maybe 2 years ago? It was only 2 years ago?
CSAIL at 16.
Wow, okay. That's been a long 2 years. Anyway, thank you all for showing up. I know we have lots of things on our mind. I will try to stem all those thoughts in my own brain so I can maybe give you a coherent talk, but I did need to acknowledge the gorilla, elephant, or whatever animal of your choice in the room. So the bulk of the talk will actually be about what the title says, so exploring how patient-generated data from wearables and ambient devices and digital health tools can improve the delivery and quality of individualized clinical care, and in particular, these terms that have evolved in the field, digital biomarkers, digital therapeutics, that are the things that convert raw data into something actionable by clinicians and patients or caregivers, things like titrating medication or augmenting treatments. So I'll give some background, I'll give some successful examples in which the work, which has in some ways been going on for not quite 20 years, but certainly a solid 15, has worked its way into actual care paths and doing a good job in certain key cases. And I'll also talk about that for this stuff to really have impact more broadly is going to require implementing things more at a systems level. And it's difficult to do these things well, sort of siloed, one condition at a time. Whether and when we'll actually accomplish that in our healthcare system is an open question, but I think it's important to try to articulate where it is we're trying to get in any case. So that's the talk, but before I dig in on it, I consulted some of my friends and colleagues and decided to indulge a bit in reflection on my rather sort of non-traditional career. Maybe we all think of our careers as individually non-traditional. No one's normal, particularly in this wonderful institution. As Dave Clark and I were talking about earlier, like, you know, we're all sort of odd ducks. I still claim that I'm a couple standard deviations out from the odd duck club. So in any case, I think because it's so non-traditional, I spend a fair amount of time trying to make sense of it for myself. How did I end up doing this? And so I'm going to indulge in a few slides on sharing that narrative with you. But then I'll come around to this topic. So I did some version of this slide for some talk to a bunch of graduate students at some university probably a decade ago, and I've like added to it since, and then I cleaned it up since then. And like I often, when I meet people, if I met some of the students today, I always want to know, like, where did you come from? Not in the colloquial, like literally, where did you come from? Where were you before this? What were you doing? So I was not born in 1974. I started high school in 1974, just to be clear. Anyone recognize that picture, which isn't me? Anyone know who that is? Gloria Steinem. So I barely had any presence. I was a nerd. I just like didn't have a social presence in high school. I didn't even know that anyone knew who I was. But they did nominate me as the Gloria Steinem of my graduating class. So I'm proud of that. And went to Berkeley, as was said, and then I came to MIT in the 80s. Very formative years. Influenced by amazing people, my thesis advisor, Jerry Salter, Dave Clark sitting here, who influenced me during grad school and even much more following it. And of course, Big Mike, after whom this lecture is named. I don't know if you can quite see the photos above do you see Jerry and a very old picture of Dave Clark and Jerry? You recognize them? Yeah? No? Dave Clark with long hair, sitting up above Jerry Salter with the tie, and then to his right is Mike Dertouzos. Anyway, very formative years. It's also that I was in the generation, along with Karen Sollins, who wrote the Women's Report. How many of you know that famous tech report, LCS tech report, Women in Computer Science at MIT? Ahead of our time in many ways. And from there, I went and, as Daniela said, I took a faculty position at USC and ended up spending a lot of my time at ISI. John Postel was the name and number czar. He had a little office and he handed out blocks of IP addresses and handed out domain names, before these things were automated. It was a time that really instilled in me this respect and desire to build infrastructure. And that's what really is the powerful thing to do. More so than the individual papers or the patents, which somehow, 65 and 40 years since my PhD, and I have never had my name on a patent. I didn't set out to do that, but it just sort of happened that way. And I grew up in an environment where architecture and such was the way to have impact. And really in a world that, sorry, Dave, to embarrass you, I won't mention you again, maybe after the next few minutes. But Dave built the IETF and the Internet Research, the RSG, and the whole thing that became the governing body of this thing that became the Internet. And it still is, even though I've wandered far, it still is sort of my native tongue of what work should look like to have impact. So as it happened, I emigrated, not really intentionally, and it was one of those things like you go and visit a country and then you forget to go back home. But I first started doing distributed and sensing, and then eventually to healthcare. So let me talk a little bit about this unintentional journey. So back in the late 90s, I had been doing multicast routing, really fun experimental technical work. I have great respect for theoreticians. I've never been one, but it was really fun protocol design work. People like Steve Deering, who started it all, and Van Jacobson and Mark Handley. And we were all taken by surprise when, after we did this great job and got the RFC published and published the SIGCOMM papers, there had been this like shift I hadn't been paying attention to, that we had massive fiber deployment. We had suddenly an overabundance of bandwidth, and multicast was supposed to save you bandwidth. And we had not implemented a single consideration for management or security. And multicast was in some sense, this potential right vector for denial of service attacks. And in the end, the big demand was not really for synchronous high bandwidth streams. And a lot of what was out there really maybe was just fine with caching. And that was devastating for me. Like, we had this project, really, that was great, and I wasn't paying enough attention to context. And it took a long time for any of that stuff to actually get deployed. I'm an experimentalist, and it was really just one of these things like, how am I going to convince my graduate students they should work hard on the next iteration of these things when I'd lost some amount of confidence because the internet was no longer something to be experimented with in its core, right? So if you were doing things below the edges in the routers, had become critical infrastructure. And nobody was going to just pick up and run it was this, okay, do I leave and go work for a router company, Cisco, or what is it, what that might be? And at the time, I was on a DARPA ISAT committee that John Hennessy had invited me onto. And I proposed a study that was like way outside my comfort zone, that was about networking across sensors instead of routers. It was just this like logical thing. Okay, I can't get experimental work to happen on routers because they're too important, and I wasn't working on like the performance within a router. So maybe if I think about networking other things, we called it toaster net and stuff like that, maybe then there will be like another interesting set of problems because multicast was so much fun to design and do. So I naively called it simple systems. I should have called it simple nodes. And I collaborated with some amazing people on that study. Mark Weiser from Xerox PARC was on that study, and your own Hari was this singular graduate student. And we were just talking before, like, Hari, how did you end up on this ISAT research study? And it was, it was his recruiting year. And it was like, wow, like you're thinking about some things. You should come and join this study. And it was wonderful. And it was the beginning of thinking about distributed sensing. And I came to it with internet architecture and protocol design, really, and multicast as my priors, right? I came to it as, okay, now we can do interesting protocol level things within the constraints of these simple nodes that are not tethered, they're energy constrained. If they're energy constrained, they need to be communication constrained. Like there was this whole story led us to do this thing called directed diffusion, which was a very cool thing to design and write about. Never saw the light of day, but was a very cool thing, and still is from an academic perspective. Meanwhile, there were also people coming into it from a database lens. And I noted this down before I heard from Sam that he wasn't going to be here, but in any case, it's just true, right? Joe Hellerstein, Sam was a graduate student, and maybe he wasn't quite yet a graduate student. It all just sort of lumps together. And Ioannis Gerke, from a database perspective, they looked at these distributed systems and said, this is like a distributed information thing, not a network. If I had to choose who was closer to right in the end, it was probably them. But when I was talking to Dave earlier today, we had a discussion about how I, at that point, moved sort of up the stack, but I hadn't moved up the stack. I thought I was moving laterally. So I moved laterally, and you were right, Dave, because moving laterally caused me to have to move up the stack. Because in our internet days, like some people in this room must have been on those like SIGCOM committees with me when we would like through some kind of, I'll say the words anyway, even though I'm one of these people who thinks while they're talking, it gets me in trouble. But anyway, that we would do affirmative action for application papers, like to have a token application paper or so. But really, we respected generalizability and being application agnostic, right? That's what led to the power of the internet, is that we didn't build application-specific, back in those days, semantics into the network. But with distributed sensing, that didn't quite hold because it was about the data. It wasn't just about transportation it wasn't just about carriage of that data. And so what you were using it for and the statistical processes you used weren't generalizable. Like I used to joke with David Culler, they were doing distributed sensing on the ceiling of a room like this to do like fine-grain HVAC control. And then I was trying to use their moats to do distributed sensing to model the microclimate within a forest ecosystem so that you could understand how small changes in temperature and humidity were going to affect sensitive flora. And the ecologists looked at me when I showed them this moat with this nice little board on it that had heat and light sensing, and they said, why do I care about the light and heat on the surface of this device, right? I need the light and heat on the bottom of the leaf and the top of the leaf because there's radiant heat and the application mattered. So when I moved from doing internet, Dave clearly knew, but I didn't know that I was just committing myself to move up the stack as well. And in doing that, I also committed to working with experts. So whether you're working in genomics or healthcare or ecosystems, I think it's rather, there's a certain amount of hubris in thinking that you can learn that entire domain and become an expert in that domain and in what you're doing on a technical level, and really do right by that particular application domain. And so working with people who are in those other disciplines just became a part of how we did things. And the Science and Technology Center that I was able to build and run was just an incredible opportunity where our sort of killer app became environmental monitoring for ecologists, for environmental engineers, marine biology. And the premise behind it was a higher density observation would allow us to reveal and understand and model previously unobservable phenomena, because we were sort of looking at things below what even the pixels of remote sensing and so forth could actually pick up. I later heard Margaret Martinosi give a talk many, many years later, and I joke with her because I've now re-paraphrased what she said many more times than she said it. But she called it from when she described her work in ZebraNet, where she was putting monitoring collars on zebras, that to do this kind of work requires taking turns. So you have to take turns between going after the domain scientist's problem that they're looking to solve with your not most exotic technology. And then you learn something about it, and then you can come back and then look at pushing the boundary on the technology you're using. Because in most cases, when you try to go out simultaneously with an instrument that you don't understand, trying to study a problem that they don't understand, you get a lot of noise. And so this whole notion of doing mission-driven work and taking turns was a lot of what we learned over this time. And we started off with this idea that it was going to be massive overdeployment of super simple nodes. And that's like this whole thing behind diffusion, that the nodes would take over for one another. And it was so much fun to design that stuff. And then as I started working with these real scientists in these real applications, it turned out that there was no such thing as over-deployment of nodes for all kinds of physical reasons. And these things were not, scattered like dust, and they're still not. So I worried at the time that as we went to meet the application folks, we were becoming more and more conservative and less forward-thinking. But 20 years later, that vision still isn't right. And we started building much more multimodal and multi-scale systems. And one of the last sort of transitions in there, you see this little guy over there on the left. We didn't have drones at the time. And Bill Kaiser and Greg Potty, great collaborators of mine at UCLA, we started recognizing that these fixed sensor nodes, it was like a huge opportunity cost in then being fixed in any one place. Because if you were trying to do something that was about denser sensing of the environment, being able to move your sensor through the environment. So this thing used a cable, again, pre-drone, to do adaptive sensing of at least that plane. And so we were very excited about mobile platforms, and then came along, that ultimate mobile platform tethered to us as humans as opposed to a tree. And that is the last in this, series of explanation, and I will then get to the talk, of that we started doing work with mobile phones as sensors, frankly, because those Symbian devices that Nokia sent us back in 2006 were so much easier to deal with than the Berkeley motes. And they already had some sensors on them and such. And we started looking at those mobile devices as sources of data, called it participatory sensing, did a report on that for environmental monitoring. And eventually what turned out to be the most useful use of that data, or clearest use of that data, had nothing to do with the environmental work. It became mobile health. So that's this unintended. I try to make sense of it by projecting retrospectively some kind of a narrative on it, particularly because healthcare is not easy to navigate. And so, and also this is a 2010 image with this traditional internet hourglass, and trying to talk about what we could be doing in mobile health if we would sort of adopt some kind of a similar architecture where we'd be able to reuse a lot of those components for a whole range of different conditions. This is still aspirational. I think it's still a good aspiration, but now let me dig in a little bit more. Okay, so this is another diagram that Ida Sim and I, a wonderful collaborator, an actual doctor, medical doctor from UCSF, did a science paper back in 2010. And the framing of this work and around this, mobile health, what then became known as patient-generated data, is to drive the feedback loops of healthcare. So self-care or patient care, clinical care, traditional clinical decision-making, and then, very importantly, research evidence or clinical studies. And my clinical colleagues and some great writers on this subject, I think, state it best. Gawande wrote this article many years ago, not quite 10, on the heroism of incremental care, and said that we should shift our focus from rescue medicine to lifelong incremental care, or leave millions of people to suffer from conditions that increasingly can be predicted and managed. And the more capacity we develop to monitor the body and the brain for signs of future breakdown and to correct course along the way, the greater the difference healthcare can make in people's lives, as well as reducing future costs. I haven't heard anyone say it better, so he's the one I quote. But from closer collaborators, I've never worked with him, Ida Sim, again, would often say that as an internal medicine doctor, when Mr. Smith came to her and was looking for what's the most effective antacid medication, and there's been a new a medication that would come out on the market, and it was proven to be more effective in 75% of the cases than the prior medication, she had no way of knowing whether he was one of the 75 or 25 that should bother, and we should be able to use mobile health-like tools to do a little N of 1 study, 2 weeks on one medication, flush out, 2 weeks on another, and be able to treat, if somebody's going to be on this medication for years, that she should be able to treat in that way. That was true then, still true now, still not the way doctors carry out clinical care for the most part. Around that same time as we were starting this, a colleague of mine from Cornell, an internal medicine doc, did really early work in electronic health records, Kurt Cole. He made this statement that there is no evidence base for patients who are taking multiple medications. So our medications are approved based on an evidence base individually for the most part. And once you take multiple medications and you take your own physiological history and genetic makeup, there is really no evidence base. And so individuals go through a lot of titration of medication. Is this medication working for you? Is this dose working for you? And then we age and the dose that was working for us isn't working for us. And finally, Hiroko Dodge, a geriatrician who I had an opportunity to work with some time back, pointed out that kind of differentiation, like what the standard dosage is, things like that, that differentiation really increases with age. When we're born, we're genetically different from one another, but we're otherwise pretty similar. And with life, and with the different environments we live in, and the different things we eat, and the different things we're exposed to, we become far more differentiated. So that's the motivation for doing work on trying to develop things that can be digital biomarkers, and even what I'll describe to you as digital therapeutics, not my term, it's a term of trade, that are fueled by this patient-generated data. Mobile devices, ambient devices, I saw Dina walk in, and wearables. And of course, I think of it as a stack, right? So at the bottom, stacks start at the bottom, right? There's the patient-generated data coming off of different apps and devices for more continuous observability. And most things that have been successful have tried to create observability for what are established measures that doctors know are relevant to a particular condition. Up at the top is the contextualized data. And so really, as opposed to trying to discover some previously unanticipated connection between one physiological parameter and a particular condition, there's been very little success in that kind of space. Rather, look for the measurements and information for which clinicians lack high enough resolution, particularly temporal resolution data. And then the interesting work is in the middle, which is developing the models that convert this raw data, which was always a non-starter in terms of actually giving clinicians raw data, and developing the models that convert that data into something that can lead to clinical action. So there's been good progress over the years, particularly if you weren't like watching the water while it was boiling. It looked like very slow progress, but we look back now, there are numbers of consumer devices and they're all being used, certainly in studies, and to some extent, some of them moving into care, which I'll say more about, and that's whether it's your Apple has been really the strongest in terms of companies sticking with projects and clinical domains from as far back as at least the last decade, and but really, and my favorite device, I don't own any stock in it, but the Oura Ring, I've been wearing one since 2018. They've made progress, used in many, many studies, not a lot of breakthroughs into actually making a difference in healthcare. My favorite exception to that is Parkinson's. And so back in the very early days, it's almost exactly 10 years ago, when I heard about the Empower study. It was a study that Apple worked on. I'm forgetting the actual research university that they worked on it with. That's very bad of me. Those people would not be happy. They were introducing Research Stack, where they were trying to, they worked on an open source platform, Apple open source platform, for people to run research studies on mobile devices. And Empower for Parkinson's was really interesting. They took the standard tapping test that a clinician can use to sort of see how your symptoms are progressing or how well they're controlled by your medication, and they put it on the touch screen of the phone. And added other things to it, like it was already well known that you could detect progression of Parkinson's because of its effect on your vocal cords. So they would have people be reminded to take an sample to then be evaluated. Move forward from that, in 2022, they have they had approval for a symptom monitoring device for Parkinson's. Why was it Parkinson's? Like, why Parkinson's as opposed to other things? Because it lends itself to what the sensors could measure, right? It's neurological, that shows up a lot in your fine motor and gross motor behavior, and that fit the very readily available accelerometers that were so inexpensive and put into mobile devices, into wearable devices. And it wasn't just that you could detect it, it's that it led to something actionable. Because Parkinson's can be managed for many, many, many years, but the medication sort of needs to be timed to cover the functional period of your day, like your work day, for example. It can have sleep interference. It's not operating your system, sort of like medications for ADHD. It doesn't operate in your system 24 hours a day. And as the disease progresses, you do need to make adjustments in the medication. So there was a real clinical loop to be closed by having this kind of measurement. I've used this slide many times before, not just when I'm at MIT, but you see in the middle there that it also, Parkinson's led to Dina's work on being able to detect and assess Parkinson's disease at a distance, of course, and through nocturnal breathing signals. And that whole notion of being able to use sleep as a time in which to make assessments is brilliant in that context, and also a lot of what I like so much about the Oura Ring. Sort of once a day, most of us stop our other confounding activities, go horizontal, and enter for some amount of time, stages of sleep. It's a really interesting sort of like natural experiment and a time in which to get some baseline measure of your clinical condition. This has moved on to work that's been able to do early detection of Parkinson's, and even some work that started to tie into therapeutics. So it's not the case, double negative. It is the case that here we have a clinical condition really well matched to available sensors. The models improved over time with more and more data collection tied directly to relevant clinical and patient action. Because some of what needs to happen with Parkinson's, it's not that the clinician is always changing. There's a certain amount of that the patient or the caregiver needs to do some amount of the assessment. Do they need to up their dose or shift the timing of their dose? This is not one of those earth-shattering great successes as is Parkinson's, but it's just an example to say that there are lots of other issues that arise in the world. This is one of the ones that interests me these days, such as we enter periods of more extreme heat, what is the impact of extreme heat on vulnerable populations, which turns out to be particularly older adults and particularly individuals with cardiac conditions or if you're taking certain medications. And it's not a well understood problem, but it's a very well understandable problem because of the state of wearables and such. And so work like this from the at the exploratory level can make use of all these consumer devices and good work that's happening on the standardization front as well. Okay, that's measurement. In the case of Parkinson's, that measurement led to an action of adjusting medication, titrating medication. A lot of other studies and things that went into measurement didn't have a compelling closing the loop, okay? So you measured something better, but what's the action based on it? And so over time, the market created this term, I think, of digital therapeutics, where you're using digital to actually help deliver an adjustment in the therapy. And it doesn't apply in all cases, but in some it does. You know, people have used VR for various behavioral health conditions, particularly around anxiety and trauma, and even some pain interventions. Some more, if you will, sort of AR for remote guidance. And so digital therapeutics has some inherent attraction to it because it's not just you're delivering data to the same people who have to act on it. You're actually using the digital to try to scale the response. In some cases, like where the VR is the therapy itself and used occasionally, it's seen a lot more success, and that's probably primarily the case. When you get to things like physical therapy, there's ways in which computer vision can guide you to do your physical therapy at home. And that's had some traction, but then we forget about the behavioral components. Like physical therapy often hurts. If you're an older adult and you're supposed to do your physical therapy, it can also be like anxiety producing. Am I going to fall? And so it's been a lot of things that even in the market that grew up around a lot of hype around digital therapeutics have since failed. But I think there are some still very important use cases. I like this one from Stanford, which takes a really excellent sensor, continuous glucose monitor, and some type 1 diabetics who are constantly adjusting their insulin wear continuous glucose monitors all the time. But for the most part, CGMs can be used to determine what is your glycemic response to certain foods. Science has shown the microbiome, et cetera, mediates how you respond to particular foods. And they use this during 2 weeks to build a model for individuals who can then go ahead and use that model of their glycemic response going forward to adjust their nutrition behaviors when they're trying to address metabolic health. Lots and lots of studies in this space. This is a slightly old, slide, but I couldn't find a cool graphic with an update on studies in the space. And it's a space where a lot of this was happening even before, whatever you like to call it, LLMs, agentic AI, whatever it is. And that I think that's where we'll see reinvigorating of some of that space as we get more patient-facing, language-based agents in support. There's another sort of tangent I want to go into for a moment related to this theme of digital therapeutics, which has to do with caregiving. So many health conditions have to do with conditions of aging, right? As we age, we have more health challenges. And as our population lives longer, we have more and more individuals with health challenges. And that's always been like the digital divide. That's always been one of the most significant digital divides, is with people who grew up and sort of native to technology. But I would say also it's not just age. When you're not feeling well, when you're recovering, when you're suffering, adopting new technology by your itself is just a challenging thing to do. And so there was, for a couple of years, one of the explorations we were doing was about using visual agents, if you will, using XR technology to bring tools to caregivers. So I at least, would like to have a human caregiver. I love robots. Daniela's not here. Okay, I'm not offending anyone. You're right there. You moved. Anyway, robots are wonderful, and I'm sure that they will be of increasing help in the home. And when my parents were still alive, we wanted humans to be taking care of them, and I still like the idea of the last meter of care being human. But I'd like those humans to have as much guidance and expert as they can. So the concept behind this was to bring superpowers to caregivers by using augmented reality in particular to have them be able to capture information. Think of your, recovering from a knee surgery, and they're doing wound care after recovery, early detection of possible signs of infection, much better than later. So all the capture that can happen, as well as being able to augment and show them what they should be doing. And even, an expert eye, a trained eye, a nurse's eye, can look at a suture 3 days later after surgery and know that it's showing signs of infection, and more than it was 3 days ago. But an untrained eye doesn't. But we can bring sort of trained eyes to more individuals. So I still think that this is an exciting area. It's tricky when the state of on the one hand, it's not really a computer vision research problem anymore. This is all relatively doable, in other words, not publishable stuff. On the other hand, the devices themselves, Microsoft abandoned the HoloLens, very sad. And the devices are not quite ready for the field. Some of the smart glasses that have come out over the last couple of years, Meta's glasses, they don't do the AR yet, but they do a lot of the capture. And it's still, particularly as this combines with language-based agents, I still think there's a lot of potential in this space. So lots of potential in the role of digital in healthcare. More and more healthcare is happening at home. Now we hear about hospital at home, shorter and shorter hospital stays, and we do need technology innovations to help in the home for all those reasons. And when I started not knowing, again, that I had sort of was emigrating again from distributed system and ecology and ending up in healthcare, and when I look back to 2010, 15 years ago, I really thought this was going to be a revolution. This was going to transform healthcare. And I underestimated, there were just lots of things that needed to come into place. We didn't even have electronic health records universally in the US deployed at that time. And now we do, for the most part, and there's much more capability and readiness within the system. And I will say that during COVID, when virtual care started being used much more routinely and started getting reimbursed, it was this is our moment. These digital tools bring so much more information to the clinician who doesn't have it when they're treating you over the effectively a Zoom interface. And I really thought we would sort of fly in on the coattails of virtual care. And again, I think that can still be the case, but it requires a kind of patience to actually get there. There's a really nice article that I found published just last month that steps through sort of what are the limitations and barriers, I added the word rapid, to adoption of these technologies in care. In a use case that is a very powerful one, I forgot to mention when I was talking about digital therapeutics, I don't know if you know what AFib is, but it's a concerning arrhythmia that's rhythm dysfunction and can lead to strokes. The reason people worry about AFib is because it can lead to strokes. And so people who have significant AFib are put on different kinds of blood thinners. And one of the digital therapeutics that Apple introduced, not in Parkinson's, but in this context, and they have a clinical study underway, is to allow you not to take blood thinners all the time because you sometimes have AFib, but to do what's called pill in pocket, which is to wear the Apple Watch when your AFib load is going up. It triggers you to go ahead and start taking those blood thinners. I don't think the results are in on that study, but the concept is really what sort of digital therapeutics and wearable into clinical action is meant to do. But this stuff is hard. In some sense, we want it to be hard. We want things to move into clinical care after they've been proven. We don't really want creative medicine practiced out in the field. We want creativity coming into the science of medicine and it getting proven out and then brought into the field. But this diagram that starts with legal and reimbursement, and really that by itself, who's incentivized to introduce this innovation? A lot of our innovation in healthcare is acquired through products, and if your innovation is acquired through products, then that innovation needs to represent revenue to somebody. Otherwise, it's not going to be a product. And so I think that working in this space is not for the faint of heart, but it's important. And a recognition of sort of how long it takes is not meant to discourage folks, but it's a level of sort of a reality check. And I think one way that you navigate it is you sort of, as we do as technologists, we move sort of upstream of the problem. We try to move forward a capability that is motivated by these problems, and it can't just be measured of, you worked on that problem, is it deployed? Because the path to deployment here is just far more complex. So I do, have this aspirational view of what clinical care could look like. I'm sure it will. I don't know when, right? Because it's very difficult. You have cases like Parkinson's, and you have cases like that AFib to stroke story. But this is usable in your child's, food allergies, and in your own management of sleep disruption. And it's really a cross-cutting possible capability. But to get your primary care physician to use it, it has to be something that they can do in a way without becoming, an expert in device deployment. So we first of all have to answer the question, how is the provider going to act on data? They're not going to look at your aura data, right? It has to come into the EHR like the result of a blood lab. They don't look at all the details in your blood lab. They look at particular parameters. They know how to use, HbA1c or whatever that parameter is in order to manage your diabetes. And so we need the clinical work that makes sure that no raw data is ever seen by a clinician, right? There's always an AI model between the data and the action. We also need to make it prescribable. Your doctor doesn't hand you your medication. There are these things called pharmacies. So if you're going to start having prescribed wearables or apps, and that's going to indicate the doctor will be selecting which data ends up getting surfaced to them and when it gets flagged or not, and you need to get those devices, you need a digital pharmacy to sort of handle that part of it, because it's not what the doctor does during a clinical visit. And while we're doing this, what are we trying to optimize for? Are we trying to optimize for timeliness of diagnosing a condition, for continuance of care, for self-care? And in the end, it's not going to be that there's virtual care, there's in-person visits, there's And then there's some of this data. There has to be like a coherent pathway for where there are clinical encounters. They take various forms, the data mediated by AI and agent technology as well makes it done. I think this is doable. The technology actually, as sort of, it doesn't really need any PhD theses to get us here, but incentivizing the system to move to this is rough. So I think there are ways to make progress as I'm coming to my close. First of all, virtual care is an inflection point, right? If you talk to clinicians who deliver care virtually, right, they lack a bunch of data. And there's a lot of room on that screen that they're staring at to overlay measures that could be coming from these devices and from these digital biomarkers. And building the models to close that loop, I think focusing on care that is sometimes virtual is a key path for deployment. And in doing that, we have to think of, there is things called care paths. So when doctors are taking care of somebody with an allergy or an endocrinological issue or Parkinson's, there's a care path, a certain type of medication and therapeutics and things that are used. And we need to design these things into those care paths. And finally, we need to make this stuff move faster and more agilely, so not doing it sort of a silo at a time. This skiddy tall buildings is a New York City joke or colloquialism, like these needle ugly buildings that are ruining the skyline, not good for anybody. And we really need to proceed with these things with modular infrastructure. Those of you at all interested in this space, what Ida, who really took on the lead of OpenM Health when I moved to New York, it's really living on and getting a real boost. There's just, they're just announcing something called Jupyter Health, which is done with the Jupyter.org organization to be used as a modular study server application. And it's really going to amplify the rate at which these studies can get done. There are a bunch of governance issues, mostly having to do, again, with just misaligned incentives in how we get things developed and deployed. I realize that in a very unfortunate context, this book, An American Sickness, hit the news a lot. I don't know if you remember that. There's been so much news. But it's a really excellent book to understand the US healthcare system. And then just sort of to end in the way that I started, a little bit of an epilogue, if you will, just sort of tying from the beginning. Lots of things I've mostly learned not from myself, but from other people, right? So there's this wanting to do things abstractly and generally. I was once on a PhD committee. I was at UCLA, and Yuta Pearl had a PhD student. And for some reason, I was on this PhD student's committee, even though I couldn't understand most of what he was doing. He was very theoretical. And he was in his PhD exam, and I asked him to give an example of what he got me to be on this committee because he said it had to do with like distributed sensing. So I asked him for an example. And he said, it's a very general mechanism. And Yuta Pearl said, the fact that you've designed, I'm paraphrasing, I'm probably butchering it, the fact that you've designed a very general mechanism does not relieve you from the responsibility of telling us one thing that it actually does. And that's this dynamic balance. Like, we want things that are generalizable, but when you're doing mission-driven stuff, like, it's frustrating, but it's pretty amazing to have like reality push back at you, right? And that's just, you know, back from internet and onward. Choose real problems that subject matter experts believe are important. So Jim Waldo, who was on this National Academy study thing we did on this Embedded Everywhere study that Barbara Liskov was on, a couple years after that, at some workshop in Cambridge, I don't remember where it was, maybe it was at Harvard, he sort of chastised, were you there? He chastised the wireless sensing community for making up problems. He said, like, you're making up, contriving these problems, and you don't know whether none of us were theoreticians, right? But we were doing like experimental system approaches to problems, and you don't know whether the solutions are ever going to be really relevant. We have so many problems in the world, like take on real problems. And which is also this thing of like work with experts who are a good judge of what's a real problem, not just sort of a problem of convenience that is a good fit to your solution. Connect those pursuits, not just about measurement, but measurement to action. And this whole idea of taking turns, which I told you from Margaret Martinosi. And then, back from internet context, like reduce, reuse, recycle, like adopting modular tools, sharing them, investing in shared infrastructure and platforms. It's not often what maybe you're getting incentivized to do, but extremely valuable. And stakeholder incentives, in the end, limit a lot of what ends up happening. It doesn't mean that what you did was a waste of time. At least that's what I tell myself often. Somebody else learns from it and does something else. But it's a very complex system out there, and we sort of have to have the patience to muddle on and try to find a way forward in this thing that we call our healthcare system. And just a thank you to lots of folks at lots of institutions. Thank you.
Let me kick it off with one question. You talked about the importance of being really technical in our field and then finding somebody who's really technical in a different field. How do you see the future? Do you think it's important to train bilinguals, or do you think it's better to have a deep specialization?
Probably the answer does not generalize. Okay. So I don't know that there's one answer. I think there will be more. Being bilingual is different from being like the expert in both things.
But you prefer to work with the expert rather than someone who knows a little bit about computing.
Oh, no. I mean, of course you work with somebody who knows about computing. Okay? Like there's glue on both sides of this. But to think that I just think it's dangerous to talk to a domain expert and believe you have the full model of that problem and take it away and iterate on your technical solution without sort of that expert in the room. So like trying to think about clinical stuff without like a doctor in the room, because we don't embody their reasoning. And I don't see, science isn't just two people anymore, so, yes.
Other questions for Debbie? Pete?
I'll try to talk loudly. Your picture of the integrated system traumatized me. Because I remember about 20 years ago when Google started building Google Health.
Yeah.
I was very enthusiastic because
Yeah.
I had proposed some stuff like that before. And then I went to see my doctor here at MIT. And I said, Doc, if I had the system, would you ever look at it? And he said, hell no.
Right.
I don't have time to do that.
Which is my point.
Yeah.
Okay, so the doctor does look at your EHR, looks at your blood labs, and they just need to be seeing something equivalent. Having them look at that raw data, non-starter.
Well, but there's a systems problem.
Yes.
Which is that whatever abstraction you
Yeah.
build has to show up in his system.
Yes. Yes, but with enough intelligence layered on as to when it should be looked at and when it needs to be looked at. It absolutely has to be both temporally and otherwise. So when you prescribe this, it comes with, you know, depending on severity of disease and whatever's going on, what would cause that data to be surfaced? Because otherwise, it is absolutely hell no. My eldest sister is an internist, like, also keeps me honest. But that's what ends up. They also have to be reimbursed for things, right? It's like there's a lot that has to change. It's very aspirational. But the point of it is exactly what you said, because it should just look like blood labs come in or imaging labs that come in.
Have you tried getting Epic to add a new data field to the displays?
Well, it's so Jupiter Health, this platform that I think is they're just doing it right. Jupiter.org, Jupyter Notebook's in the middle, right? I'm not saying that's the height of whatever, but it's a good thing for experimentation. And they put in the layer that connects it to your HIPAA-compliant data store, the IRB studies, and they generate smart on fire things to come into the dashboard. Look, before blaming it on Epic, we have to do the clinical research studies that show that this is worth doing. And yes, I think in the end, even Epic will do it rather than let somebody else do it.
Yeah, so you mentioned Parkinson's as a good example, one positive example, but do you have a way of like framing things to better understand other things like Parkinson's that could work out, like could be positive examples? Like how do you generate things like Parkinson's?
Yeah. How do you choose a problem that has that potential? And do recognize that that's a 10-year history. So if you're trying to get it all done from beginning to end, while you're, you know, it just keep that in mind. I think the sensors need to match the condition, and what you're measuring needs to match a clinical challenge that they have. So I think these, if you look at the AFib to stroke risk reduction, if you look at Parkinson's, they both have those characteristics. Even the continuous glucose monitor for managing metabolic. So you look, I'm technologist, right? Of course we are hammers looking for nails. Because what else are we going to do if what we design are different kinds of hammers? Now, there are many different kinds of nails, and there are many different things that get built with those nails. The metaphor, I don't like metaphors. I never know where somebody's leading me with them. But you have some expertise, you have an idea, and you go around looking for where that phenomenon might be measurable. But you don't just like, I found it and I'm done. You have to go the rest of the way and talk to enough people who are in the business of treating those conditions to see if better measurements are actually going to lead to some action. And I think you forget about the incentives and the reimbursement and will the payers pay for it. Like, don't take that in your head unless you're going to start a company, right? Leave that out for now, but see if there's actually a clinical loop that can be really effectively changed for the purposes of the physicians and the patients, and they have those characteristics.
Just kind of a follow-up question, like, do you view this problem domain as like a place where there's so many nails, it's just we don't have enough hammers or we don't have people to hit them, or like very small number of nails and we're really trying to find those gems?
I told you I hate metaphors.
Yeah.
Okay. Look, it's a rich area, but it's a very selective one of what ends up working. So, you know, it's like lots of things. I think, you know, we see it in genomics and lots of things. Like, there's so much potential, and how much of that has moved, you know, been able to move into care. But it's worth it, right? It's worth it, maybe not with all of your time. So I have this big project that I help run, and for most part, the PhD students and the postdocs are 50% time on this medical project and 50% time on things where but like the paper generation, and then like you can just turn that crank more effectively.
So I think time's up. Let's thank